Hello, good morning to all the students. Okay, we're going to see today how many is watching, and we just got 9 students is watching. Okay, for the student, you are on the line now. Can you feedback for me? You can listen me and you can see me or not. Okay, so if you can, that means our lesson will be continue now. Okay, anybody here? Okay, morning, Iru. Okay, can listen me or not? Okay, good morning, Zihui. Okay, morning, Khatijah. Okay, if all can listen me, that means I can start my lesson now. Okay, thank you, Iru. Okay, so I go to change my layer first. Okay, so today I want to continue the chapter 5. Okay, chapter 5. Okay, chapter 5, this one I discuss about for you for your exam lah. Because one of the exam is after the holiday of the September. Okay, they got one of the short exam. The exam is 1 hours, and also there should be the Sararas. That means the whole form 5 should be Sararas. And also the physics, they will cover about the chapter 3, 4, 5. Okay, 3, 4, 5. Then after that, you need to finish today the lesson. Today the lesson chapter 5 should be the last one. I want to make sure first I not confirm there's a 3, 4, 5 or 4, 5, 6. Okay, I need to confirm that I told you for the next lesson. Okay, so from here we need to complete the chapter 5. Chapter 5 must included. Okay, must be included. So from here we go through to chapter 5. Okay, one more thing forget to tell you, there should be the structure question. Okay, we never set up for the objective. We set up for the maybe one essay question, then the rest should be the structure question. Okay, so we just start with the lesson. Okay, from this topic, we're talking about a component electronic that is a transistor. Okay, before that, we learned about the diode, is it? Now we go through the transistor. Okay, transistor is one of the electronic component that has 3 terminal. Okay, 3 terminal. First one we call emitter, then we got base, then we got collector. Okay, let's see the diagram. So this one is an electronic component. Okay, electronic component transistor. So they got 3 terminal. So these 3 terminal, they got different name. So one we call base. Base at the middle one we call base. Then at the side one, either one side they call emitter, and another one should be the collector. Okay, when you see the name, then you understand actually what's the meaning lah. Collector means they want to collect all the current. Then the collector, after that they got emitter. Emitter, that means all the current that will emit go there. So this one is the name for the 3 terminal of the transistor. Okay, now we go see this one is actually transistor, they how to build. Okay, remember what we learned about PN junction? P and N, that one is a semiconductor, is it? So when I add another N, so they become transistor. Okay, some will ask, only N, can I add the P? If you add the P, so that means you must create P and P. That means the N will at the middle, then the side should be the both P. So become P and P, there also is a transistor. So that means transistor, we got 2 type lah. Either you say NPN, either you say PNP. So another one, you need to see the structure. The structure for the middle part, the middle part should be thinner. Okay, compare the both side. Okay, let's see example. This one Mpn, is it? So the N type become bigger size. Then the P type at the middle, they become smaller size. So this one is a design. So later we need to explain why they need to design become like this. Okay, so now we go see the explanation for every terminal. Okay, first one, emitter. Emitter is supply. Okay, from here they say supply. So supply, normally you want to see the situation is the arrow. Later I will show you the arrow. Okay, the arrow will be up and also the down. Okay, one more thing I told you. Okay, please don't refer this one symbol. This one symbol got a little bit mistake lah, because the arrow sometimes they put up, sometimes we put down, is it? So this one will make the student then not so misunderstand. So important, we just always remember up is a C, center is a B, then the bottom is a E. So what changes? The arrow can be changes. The arrow can be out, the arrow can be in. Okay, so the arrow out, we got Mpn. If the arrow in, we call Pnp. Later I teach you how to remember Pnp and also Mpn. So from here, we're going to see the definition for every terminal first. Okay, emitter that supply the charge carries to the collector. If I say emitter supply, so that means this one arrow must be up lah. Okay, so that means this one explanation that explain another type of the transistor. So base is a thin layer. Remember, base is a thin layer in the middle of the transistor. They go to control the flow of the charge carries from the emitter to the collector. So that means this one explanation, they will explain about the direction is in from the emitter, go to the collector. So that's why they said E supply the charge. So B at the middle, suppose the B, they never supply any charge lah. They're just at the middle only. Okay, middle person how to transfer the charge. Okay, so from here, collector is the last one. They go to receive the charge. Okay, if I say I want to explain for this transistor for every terminal, okay, what is the definition? Okay, so from here we can see C is a collector. There's a supply the charge. Then after that, the B is the same lah, because the B is no changes. They're still at the middle. And the E is what? E is an emitter. Emitter means they receive all the charge. Then after that, they want to emit. So this one is a definition for another type for transistor. Okay, depend for yours. So normally we using the arrow is out lah. Okay, we using the arrow is out. This one is a NPN. Okay, after I finish to explain the terminal, what's the function? So now we go through is a next part. Transistor is an electronic device. Function is what? Okay, we got two functions. First one, they can become the amplifier. Example, your microphone. Okay, your microphone is a one of the amplifier. That means they can increase the output current. That one we call amplifier. Okay, another one, they can become automatic switch. Okay, example, you set the situation, normally is a lamp street lah. Okay, in the side, the traffic, you can see about the lamp street. So during around 7 o'clock, the automatic, all the lamp will on already. So that one we call automatic switch. That one also using transistor. Your house also can be set. Okay, maybe your house, you set the light when just dark. Okay, surrounding just dark, then the light in your house automatic they will on. So that one we call automatic switch. Okay, there are two types of transistor. So first one, we call it as a NPN. Another one is a PNP. Okay, now we see the structure first. Okay, now you can see the structure. NPN, okay, one side is a collector, another side is an emitter. So another one, base. Okay, base must at the middle. Okay, if I say PNP, so collector, emitter. So collector and emitter, the position must be the same. Okay, then the center sure is a base. Okay, so remember how to create the transistor. They must have the diode. Remember the diode, add another N type or P type. Then the joint become PNP and also NPN. So we only got two types of transistor. Okay, now we're going to see the structure, NPN and PNP. Okay, you can see this part, NPN. Okay, base is at the middle, collector at the top, then the emitter at the bottom. So you can see the arrow is out. Okay, the arrow is out. Means the current from the C go to the B, then out. Okay, the current also can from the B straightforward out. So if the current from the B, they cannot go to the C already. They only can go up, go to emitter. Okay, then the collector, they also cannot go to the B. They cannot say C go to base. No, collector also only go to the emitter. So emitter finally sure is the biggest one because they collect all the charge. Okay, how about the Mpn? Mpn is the arrow go in. Sorry, this one is a PNP. Okay, I label first. Got some student later that mistake. So this one should be the PNP. 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 Okay, this one should be PNP. Then we go through. Okay, PNP. So from here, PNP at the top still collector. We never change. At the bottom still emitter. That is a base. So from here you can see the arrow is go in. The arrow go in actually what's the meaning? The emitter, they provide the charge. Okay, provide the charge, they can go to the B. Then after that, they can go to the C. So finally the conclusion, which one is the most of the charge? Emitter. Emitter sure is the bigger charge because they go to divided the charge. So from the Mpn, emitter also biggest of the charge. Why? Because they keep all the charge from the C and also from the B. So conclusion, Mpn, Pnp, which one terminal get the most charge? Sure is a emitter. Okay, emitter function can be separate and also can be keep back. So this one is an emitter function. Okay, the arrow in the symbol show the direction of the current from the B to the E. Okay, from the B, they go to the E. Okay, this one arrow, the symbol show there's a direction from the E to B. The current from the E go to the B. Okay, so this one is what we're talking about, Mpn and Pnp, the arrow that will make it differences the current how to flow. Okay, B and E, but they never touching about the C because later we need to explain why the C never touching. We just talking B and E. Okay, so from here I want let you to easier to remember. Okay, let's see this one. Npn, never point in. So never point in means the arrow must be out lah. Okay, so you remember this one, the red color word Npn, so never point in. Okay, how about this one? This one, the arrow is in already, is it? So this one we call Pnp, point in permanently. Point in permanently. So they always will be point in. Okay, so this one just guide for you how to remember the arrow for Mpn and also Pnp. Okay, hopefully you understand about this part. Okay, so I continue to the next. Okay, flow of the current in the transistor. Okay, how the current go to flow in this one transistor. So when you see the diagram, actually we got two parts. You need to observe for the two parts. First one is a B. Okay, the B we call base circuit. Okay, this part, you can see this one is a 1.5 double story lah. So the higher one double story, this one is a collector circuit. So we separate by two. Base circuit and collector circuit. Finally, all will come up to the emitter. So this one is a NPN. Okay, transistor NPN because the arrow is point out. Okay, never point in. So transistor circuit, they divide by two circuit. One is a base, another one is a collector circuit. Okay, current flow in a base circuit, so we call IB. Okay, IB stand for current in base circuit. Okay, so normally from here, we just using the symbol. Then make sure you understand lah. So anything in the base, so we just label they got B. So just like this one, resistor at the base. So we label by RB. Okay, current in the collector, so we label by IC. Okay, current in collector. Okay, from the NPN transistor, IE is produced from the combination of the IB and also IC. Okay, IE. IE is the current at the emitter. Okay, current emitter is come from where? From the IB and also IC. So that means finally the current emitter should be the biggest one because they collect all the current. Okay, so this one is a NPN transistor. Okay, then we need to go opposite one, the PNP. Okay, PNP, you can see the direction is opposite. Okay, the current is at the bottom. So now the current is start from the IE. They will go to IB and also go to the IC. So that means PNP, your arrow, when just draw the transistor, you need to reverse the arrow. When you just reverse the arrow, that means the current, the terminal of the battery, you need to reverse. That means now all the current must start at the bottom. Just now the current is start at the top, is it? Come down. Now it's the terbalik. Now your transistor is up. The arrow is point in permanently. So that means now the arrow must be in. So from here we go to explain PNP transistor. From PNP transistor, now IE is split. Okay, they never collect, they go to split. Split to the IB and also the IC. Okay, so you can conclude that IE actually is what? IE is a IB plus IC. Okay, because they go to split. Okay, from here we can make a conclusion. IE sure is the biggest one. Okay, current emitter sure is the biggest one. Then after that we got IC and IB. Okay, from here we find it IC. Current in collector must be higher current in base. Okay, later this one we will go to explain why IC will be bigger than the IB. Okay, just now I told you transistor, what's the function? Amplifier. So that means they want to produce the final result should be highest voltage, is it? So final is from the IC. IC is the final part. So final part should be the highest. Okay, highest result lah. Example, highest voltage, highest current also can. Okay, so from here IB is always smaller than the IC. So they become amplifier. They can amplify the output. Okay, now C. Transistor only can be working when they just combine with the resistor and also power supply. If don't have any resistor, don't have power supply, actually they only just transistor. Okay, you want to become one of the circuit, that means you need to join. Okay, you need to join the battery and also the resistor. Then after that, they become one of the complete circuit. Okay, so this one just introduce for the PNP and NPN how to join the circuit. Okay, remember when you're just using PNP, your terminal all must reverse. If you're using NPN, so the top one must be positive lah, down must be negative. So this one is very important. Okay, but normally for the question, they're just using NPN. Okay. Okay, now you see the two type of the transistor circuit. Okay, first type transistor circuit, they only need two cell. Okay, just like another one should be the circuit 2, they need only one battery. Okay, we see what's the differences. Okay, this one is just now what I show you. 1.5 double story. They only they need two battery. You can see two battery. Base circuit got battery, there's an E1. Collector circuit also got battery, there's an E2. Okay, so the current how to flow? The current start from the E1, then flow until emitter, then go back. So this one from the E2, they start, then they flow to the emitter, then go back. Okay, so this one we call 1.5 story, they need two battery. If they only one battery, actually cannot function. If I say base got E1, no E2, so that means the base only go to emitter, because I told you the base cannot go to collector one. Okay, if I cut E1, I only put E2. They also cannot function. E2, the collector only go to emitter. They cannot go to the base. So when this one situation, you must have the 2 battery. Then the transistor can function. Okay, how about this one? This one only need 1 battery. Okay, what situation we need 1 battery? When there is a double story. Double story means you can see 2 level is the same lah. So from here, the battery, they start. When they just start, they can go to R2. They also can go to the RX. So that means they can go collector. They also can go to the base. So this one we only need 1 battery when they are same level. Okay, double story lah means the level is the same. Okay, when you find it, there's a 1.5 double story. So that means you find it, they need 2 battery. Then the transistor can be functions. Okay, let's see how to start. Okay, the current, they will start from the E1, then go to the base. Okay, another one should be the E2 lah, they go. Okay, so from here you can see this part. This part, you can find it. The current when just start, they never go to R2. They go to RX. They go to the base. Then after that, go down. Okay, this one is later we need to explain. Why become like this? The current when just start, they never straightforward go to collector, but they go to the base first. Why become like this? Okay, so this is one of the questions we need to explain for the transistor. Why become like this? Okay, so from here they go to the RX, then they go to the base. Okay, finally go to emitter. Then how about the IC? How come got IC to produce? So this one is the question. Why become like this? Okay, then we go through to introduce first every label. IB is a base current. IC is a collector current. R1 is a base resistor, is it? What's the function? Why they put R1 here? The R1 actually they want to limit the current. Don't make the current too large. Remember, current and resistance is inversely proportional. If I put resistance there, that means I block a little bit current. So that means important, the function for the R1 to limit the base current go through transistor. Okay, they don't want the current too large, and then after that they will spoil the transistor. Okay, E1 is what? E1 is a supply the energy and to the IB. Okay, IC, then we go to R2. R2, this part. Okay, R2 can be said to limit the collector current. Okay, they want to block the collector current. You also can say become the resistor divider. Okay, they can divide the potential difference. So that means when I put 1 R here, that means you separate the potential difference. Okay, make the potential difference become drop a bit because got resistance. Okay, you can say about the voltage divider. Divide the voltage when I put resistance. Okay, E2 also same. There's an energy supply to the IC. So every label, if you still understand already, so that means we can continue to the next part. Okay, continue to the next part. We never mentioned the name already. We just say IB, IC, R2, R1, then you understand. Okay, so you see the transistor, first one, what's the function? Transistor can become the potential divider. Okay, why become potential divider? You see this diagram. Okay, double story using 1 battery. So the battery is 6 volt. So this one is a total volt, 6 volt. Okay, after that, when it just up, you can see the red color arrow. The current, they will start go to the R1, R2. Then finally got RC. Okay, they must go to the R1, R2 first. Then finally RC, then the last one go to IE. Okay, so from here we separate by 2 potential difference. Okay, this one is a battery voltage. So this one is R1, this one is R2. So we label this part, upper part is a part 1, down part is a part 2. So V1 and V2 actually they are voltage divider. V1 plus V2 actually is a 6 volt. Okay, but you can say now it's a 10 ohm, this one 10 kilo ohm. Okay, they are sharing half. If I say this one 3 ohm, 3 volt, this one also 3 volt. Depend the resistor. If this one is 5 kilo ohm, this one is 15 kilo ohm, so you need to do the calculations. You cannot say divide by 2. So this one we need to depend for the ratio lah. So that means remember when starting V1 until V2, the sure is a 6 volt. Okay, if you know V2 how many, then I understood V1 is how many lah. Okay, if I say this one 6 volt, V2 4 volt, then V1 sure 2 volt. Okay, remember this one we call voltage divider. So how to divide? Depend resistor. Okay, resistor R1 and also R2. Okay, they got one of the formula let you to faster to do the calculation. From this one situation, you no need to find current. Okay, normally V equal IR, you need to find the I, is it? Okay, from here, R1 and R2, actually the current is the same because this one is a series. Okay, this one is a series. But from here, we never using the calculation for current. We straightforward apply the formula. Okay, if we want to find V1, the formula is a R1 over R1 plus R2, then multiply V. V is a total voltage. If we want to find V2, V2 is a R2 over R1 plus R2 multiply V. So this one is a one of the short formula let you to faster to get the answer. Okay, when the question they want to find V1, when they want to find the V2. Okay, so from here, voltage divider V1 plus V2 actually is a V. Okay, so from here we need to apply this one formula lah for some of the question. Okay, let's see the question. Okay, example 1. So the student, you prepare the calculator, then you later give me the answer. Okay, the figure they show about transistor circuit. Okay, so we show the diagram first. Okay, resistor P. Okay, we take the resistor P is a 2. Resistor P has a resistance of 10 kilo ohm. Okay, P is 10 kilo ohm. In order to light up the bulb, okay, the bulb is here. The potential difference across the resistor P must at least 2 volt. That means you want to on the bulb, at least you must got 2 volt at the P. So if I say 2 volt at the P, understood the Q is how many volt? The Q is a 4 volt. Okay, so what is the maximum value of the resistor Q when the bulb light up? So they never say I want to light how many up. They just say I want to bulb to light. So minimum 2 volt then enough lah. But the problem they want to find what is the R or what is the resistor Q resistant. Okay, they want to find this one resistant. So from here we label this one is a 1, this one is a 2. Okay, then I write the info. RP. RP is what? RP means R2 lah. R2 is 10 kilo ohm. Okay, because the question provided. Then the VP. VP means minimum voltage. How many? 2 volt. Okay, RQ we do know. They want you to find what is the resistance of the resistor Q. Then they tell you total volt is a 6 volt. So that means the question now they want to find is a R1. Okay, they want to find R1. So from here, actually both formula also got R1. Okay, but the problem is we do know VQ. Okay, some student will say, I take the 6 minus 2, then I know the VQ law. Okay, this one is what I tell you, but normally we never using what we go to assume. Okay, we using all the info provided. Okay, don't using the info you go to minus by yourself. Okay, so we're still using VP. That's a 2 volt. We calculate the P part. So P part is a V2, is it? So I'm using formula for V2. V2 equal R2 over R1 plus R2 multiply the V. Okay, so the V2 now is a VP lah. So this one is a RP lah. RP over RQ plus RP multiply V. Okay, so anybody here can give me the answer for the V for the RP. Sorry, it's a RQ. Okay, RQ. I want to find RQ. That means the resistor 1 is how many? Okay, we just apply all the thing in. Okay, important you know the formula. Okay, VP we know already. VP is a 2 volt, is it? So RP is how many? RP is a 10 kilo ohm. Then RQ we do know. Then we got another 10 kilo ohm. You need to plus. Multiply total volt. There's a 6. Okay, you need to tell me is a RQ is how many? Okay, I give in all the info in already. So 2, this one is a 10K, 10K ohm. Then this one RQ, we do know this one also is a 10K ohm. Then multiply with the 6. Okay, so what is your answer? Okay, anybody here, just press your calculator, then give me the answer. Okay, so the student here, who is that? Hiru, can you press the calculator, give me the answer? Okay, or anybody lah, you are fast, then you straightforward to type the answer here. Okay, anybody? Dandridge, can or not? Jaya here or not? Okay, we're going to be sure. Okay, Ling Han give me 20K ohm. 20K ohm. Okay, so we're going to check. Okay, we go to put in all the thing. Okay, so the 2 you need to multiply. So after that, when I just multiply the K, I need to minus lah. 60K minus 20K become 40K. Okay, then the 40K divided by 2. Yeah, the answer is a 20K ohm. Yeah, correct. Khatija also correct. Ling Han also correct. So remember, you want to write the full also can. You want to put the kilo also can. Okay, so this one is how we go to apply the voltage divider, the formula. Okay, there are 2 PN junction in the transistor. Okay, we must be careful. Okay, first part, I want you to focus to the base circuit. Okay, base circuit then join with P and also the N. PN. Okay, remember transistor? Remember the diode PN junction. So P and also the N. Okay, we just ignore this one N first. We go through the base circuit. So this one is a base and also emitter. Okay, so you see the connection. This one is a positive. Down is a negative. Okay, so from here, the positive is start lah, is it? Start the current, go to the P-type semiconductor. Okay, then this one negative, they join with the N-type semiconductor. So this one actually is a forward bias. Remember forward bias? Forward bias means the current can go through. Okay, because your connection is correct. Okay, your connection is correct. So from here, we go and check forward bias, what happened? Okay, this one is a B, then this one is a E. Connection terminal is correct. So we continue. Okay, BE junction. BE junction means the base and also emitter. So this one is a forward bias. Understand forward bias? Forward bias means the current can go through, then the PN junction become narrow, then after that the electron and the hole can be moved. That one we call forward bias. Okay, let's see here. This one is a number 2. Number 2, I want you to observe NP. Okay, for number 2, there's a negative and positive. So you see the terminal. This one terminal is a positive terminal, but they go to join N-type. N-type is a negative type. So that means collector circuit actually is a reverse bias. Excuse me. Okay, second circuit, this one, the collector circuit, actually is a reverse bias. So reverse bias means the current cannot go lah, is it? But finally, the transistor still function, although there's a reverse bias. Why? So this one is a problem. Why they can function although there's a reverse bias? So that's why I told you they must depend for the base circuit. If no base circuit, collector circuit cannot function one, because there already is a reverse bias. So they must depend for the base circuit. There's a forward bias to help. Finally collector circuit can be functioned. Okay, now we're going to see how come the base circuit can help the collector circuit. Okay, next. Okay, I'm going to change back. Okay, BC. BC junction means the base and collector. So this one is a reverse bias. So BE junction forward bias means P type they connected to the positive. So become forward bias. Okay, BC junction means reverse bias. Why? Because the connection is terbalik. N type join positive terminal. So they produce reverse bias. Okay? Okay, R1. R1 function is what? Limit base current. Can limit the base current go through base circuit. Okay, R2. R2, you can say they limit the collector current. You also can say there's a voltage divider. Okay, make the voltage separate. So they say voltage divider. Okay, excuse me. Okay, now we're going to see this part. How the current flow in transistor. This one is important. Just like I told you, base current can function, just collector current cannot function. So they need to depend the base current, base part. Okay, how they go to depends? Okay, we see this one structure first. Okay, this one is NPN because you see the connection, the connection battery. The top is a positive, down is a negative. So this one Mpn. So that means later, the current will start to flow, go to the base, go to the P, then go down to the emitter. Okay, can you see the small arrow? The small arrow is stand for the negative. That's an electron. Electron move opposite direction with the current. Okay, move opposite direction with the current. Okay, so emitter, this part, finish for the base, we see the collector part. Collector part also got moving. Can you see the electron got moving also? Then the current start to move. Electron start move, current sure move one, because you got charge to move already. So important is I want to make electron to move in the collector circuit. When I just can make the electron to move in the collector circuit, means the current can start already. So remember how to make the collector circuit function. I need to give more electron pass to the collector circuit. Then finally, collector circuit produce current. So the important is how to make electron go to the collector circuit. So this is one of the question for the transistor, how to make it. Okay, what happened in the base circuit? Base circuit forward bias lah. Just now I show you the diagram, the video forward bias. That's a no problem. Okay, first round, when the circuit is switched on. Okay, when the circuit on. So that means this one switch is on. BE junction forward. Okay, BE junction is forward. This one P, this one N. So the current can start to flow lah. So from here, depletion layer, what happened? Narrow and low resistance. Majority electron in the N semiconductor flow E to B, because E is a N, B is a P. So negative, there's an electron, go to fill in the hole. Okay, go to fill in the hole. Okay, C, focus to the C. Number of the hole in the depletion layer decreases. Is it? Electron jump. When the electron jump, they go through to the hole. Then the depletion layer, the hole will be less because they covered by the electron. So therefore, very few electron combine with the hole. Finish already lah. The electron combine with the hole, then the hole finish, then the electron extra. Agree? Because your hole just a little bit ma. Okay, remember I told you the P. This one P-type is the thinner layer. If the thinner layer means inside the hole is very, very less. So the electron from the N-type that need to jump. When they just jump after the PN junction, they want to fill in the hole, is it? Now your P-type, the hole is very, very less. So from here, what happened? They say very few electron combine with the hole. So now you got extra electron already. The electron too much. Some of the electron will flow into the base circuit. So electron flow in the base circuit lah. When I just go into the base circuit, no problem, because electron is an opposite direction. Then the current is a go to the right. Okay, electron is left, then current go to right. That's okay, no problem. Electron start to move, current start to move. Okay, so this one means forward bias, no problem. Then after they go to the base circuit, they still got electron. The electron is too much already. So from here, the rest go where? They will go to the collector circuit. So this one is one of the process to make the collector circuit can be function. Okay, important must is the base circuit. Okay, base circuit, when it just connection is forward bias, so that means the electron in the N-type, they will drift. When it just drift to the P-type, P-type is a small layer. The hole is not enough to cover. So you got extra electron. Extra electron, they can go two way only. One, they go to the base. Okay, when they just go to the base, that means they trigger the current go already. Because electrons start to move, then the current can run already lah in the base circuit. Then you still got extra electron. Go where? They must jump until go to the another N-type. Remember, we got Mpn, is it? Now you jump the P, then you jump until you go to the N. Okay, N-type also got electron, is it? Now electron go to electron some more. So that means now you are extra electron in collector circuit. Okay, extra electron, what happened? So the electron must be start to move already like, because you already is an extra. So from here, we must see the current start to flow from the positive to negative. Then the electron will move in the opposite direction. Okay, so this one in base circuit, what happened? We go to info, some info let you to know. Most of the electron from the emitter, they will attract to the collector. Okay, because extra, is it? Get through the base because first, base is a thin. A few hole can be filled by the electron. Number two, the collector voltage is bigger than the base voltage. So that means the power supply at the collector must be higher a bit compared to the base voltage. So the majority of the electron are pulled to the collector. Because just now N-type not enough. Now your electron extra some more go to jump to the N-type. Now the N-type full of the electron. When it's just full of the electron, now the voltage from the collector, they want to pull the electron to come. Okay, when they just pull the electron to come, then you can imagine more electron move in the collector. Then what happened? The current start, look. Is it? Must the electron start to move first, then the current will start, is it? Okay, so this one is how the transistor function. So I can make one conclusion is no base current, sure, no collector current. This one is a sure one. Because collector current is depend for the base, is it? If I say IB 0, understood, your IC sure 0. Okay, then the current in the collector must be higher. Why? Because they're using potential difference is a higher for this one battery. Okay, collector battery must be higher. compared to the base potential difference. Okay, now we see the collector circuit, what happened? Okay, BC junction. BC junction. This one is a C, then this one is a B lah. BC junction means a collector circuit. There's a reverse bias. So therefore, the electron cannot flow from the collector to the base. Okay, the electron cannot flow from the from the collector, then go to the base. So from here, what happened? The electron are attract across to the base collector. Electron attract, okay, drift until go to the collector due to the base collector junction. Then after that, higher potential difference pull the electron to go. Then finally, the flow of the electron to the collector then produce collector current. So this one is how to produce a collector current. So this one is a reverse bias. So hopefully you understand how the collector circuit can get the current. That's always based on the base circuit. No base circuit current, sure, no collector current. Okay, so transistor as an amplifier. Okay, as an amplifier means you see the potential difference. For the base, only 1.5. For the potential difference in the collector circuit, there's a 6 volt. So they're always bigger volt. Why? Because they want to pull the electron. So from here, transistor can become amplifier. So observe the brightness of the bulb. Okay, when switch is open, what does this indicate about the base current and also collector current? So from here, we get the answer is, okay, when the switch is open means nothing lah. They never join the circuit. So M1 actually cannot light up because you know current. So if you know current, understood, IC also no current. Although you got 6 volt, okay, you got S2. Okay, S2 you close or open, never mind. Important is a S1. If you S1 just open, you never join the circuit, actually is nothing. Okay, actually is nothing. Then how about the circuit? Circuit is not complete. Circuit for the base is not complete. Okay, transistor is not turned on because you know base current. So this one transistor cannot function. Cannot function means collector circuit also totally cannot function. Okay, what happened? Because the base current is a 0, then understood collector current also must be 0. Okay, all must depend for the base. Okay, second situation, what happened when the switch is switched on? Okay, now they're on already. What happened? Okay, M1 sure get on already lah, light on, but dim. Okay, because potential difference is very small, dim. How about the bulb 2? Bulb 2 light up, then brightly compared to the bulb 1 because potential difference is higher. Okay, RB has a high resistance, base current is very small. Okay, this one is collector current is larger compared to the IB. So this part they produce bigger current compared to the base current. So from here conclusion, biggest current is where? IE. Remember IE, emitter sure is the biggest one because they collect all the current. IB should be the smallest one. Then the IC is the middle one. IC the current bigger because potential difference is higher. Okay, so they become amplifier. Input base, output collector circuit. Okay, so they become amplifier. That means the final output should be the higher level. Okay, so what is the requirement for the transistor to switch on? Requirement must a small base current can produce minimum voltage. There's a VBE. So I zoom for you. Where's a VBE? VBE is what? Okay, you only using small current, enough already. So to turn on the collector circuit, okay, at least you must turn on the base. Okay, a base voltage, there's a VBE must exceed how many? Junction voltage. Remember the junction voltage? Okay, so that means you must forward bias lah. Junction voltage only 0.7. Okay, if you more than 0.7, there's a nothing already. That means you can over the junction voltage. So from here, number 4, can you compare the base current and the collector current? Sure, collector current more than the base. Okay, another one is, in a transistor, the base current switch on the collector current. Okay, so that means important is a base. Although the space is very small, never mind, important they switch on. When I just switch on, that means I can pass through the transistor, then the collector circuit can produce bigger current. So important is a base. Okay, so today lesson just until this part. So I just mentioned about the transistor structure, how to function for transistor. I still not yet go through about the application. Okay, application I just go through amplifier a bit only. So the next lesson must be go to application for transistor, where we go to use the transistor. Okay, so this one, make sure you go to understand transistor, how to function first. Okay, every structure and also base circuit and collector circuit, how to function. So this one you need to understand. So later we can apply in the big circuit, then related with the applications. Okay, so from here the lesson just until this part. What you need to do, you need to do the Google form for today's lesson about the understanding of transistor, the structure. Okay, how the current moving. Okay, so today we got one of the code. The code is a base, BASE underscore 2021. Okay, you can help me to type there. Base, BASE, capital letter, underscore 2021. So today code lesson. Okay, you can key in your Google form for today attendance. Just a few questions, let you to understand about the transistor. Okay, anyone can type there. Code base underscore 2021. Okay, anybody can help? Capital letter, all using capital letter. Okay, base, then you put underscore, then you put number 2021. Okay, so I go to share. Okay, this one is today lesson code. Yeah, correct. Jaya and Mei-Ling also correct. Okay. Okay, so from here, you go through your Google form to finish the exercise. Then I want to know you understand or not understand. No need to ask your friend. Okay, you do by yourself. Okay, so today's lesson just until this part. The next lesson should be the series 2 lah, for the transistor series 2. Then after that, about the application for transistor. So everyone, just thank you for your attend my class. We also finish 11:30. Then we finish already. So everyone, just thank you for you to watching. Okay, bye everyone.